resume the recording and let's share my screen. Okay, can you see my screen?
Yes.
Yes.
Cool.
Yes.
Okay, so let's start with testing and TDD. So basically, the agenda it's nothing more than a basic introduction and concepts about TDD and some test, what is test doubles, test libraries, and some test types. And this thing is not updated because it's from the solid. Okay, so let's start with what is TDD. Some of you who have done TDD, how would you describe TDD?
I would say that it's driving development from tests. So writing what you expect to happen before starting to actually code in a way that you write a test that's failing and then make the minimum code to make the test pass.
Cool. Yeah, so basically that's the definition, is test-driven development. So it's based on the XP and it encourages simple design with a high level of confidence. Why high level of confidence? Because we have our code tested, all our code tested. So one of the important parts of TDD is that these tests have to be automated, okay? So basically we have here like the basic diagram of TDD. So first we write a test that fails and it's going to be what we call red. Sorry, all tests of code that have not been yet implemented are going to be red, obviously, because they cannot pass. The second stage is that we have to write the simple and minimum code to make the test pass. So that's what we call the green. And then we have to refactor the code, keeping the test green. So to all this cycle is what we call red-green refactor. Okay. So is everything clear by the moment? Yep.
Yes.
Okay.
Yes.
So let's start with why TDD. Before we move to the following slide, imagine that I tell you, okay, so I want you to make me a recipe of, I don't know, pollo al limón with almendras, for example, chicken with almond and lemon. And you don't know how to make chicken with almond and lemon because you have never done chicken with almond and lemon. So what's the first thing that you would do if I ask you to do this dish that you have never cooked before?
Looking for a recipe on the internet.
That's it. That's it. Yeah. So instead of just starting mixing the ingredients and all the stuff, you would first look for the recipe, right?
Yeah.
So that is like what I think TDD is, right? So we start by the recipe, by saying how we want our program to work and what we want it to do, and then we implement what our test says. Okay, so I think that's like the main idea. So basically, why TDD? It helps us to the design of the project, of the program, because by thinking first on the test we need to implement, we focus on the design of our code. It also allows us to implement high quality software, avoiding jacknix and other programming anti-patterns such as keys and dry. I think that we talked about this on the previous workshop, but jacknix stands for you ain't gonna need it. So it's what basically tells is that you do not have to write code that you don't know whether if you're going to need it. So just keep that decision of writing code that you don't know whether if you're going to need it for the last moment when you are 100% sure that you are going to need it. Keys stands for keep it simple, stupid, and basically is keep it simple. I mean, do not over-engineer anything. Just keep it simple. The simplest piece of code is what we are looking for. And dry stands for do not repeat yourself. Okay, So it happens a lot that we might find some code that have two functions, but in separate components that do basically the same. But because we don't have like that control over the program, we don't know that it has already that function. Also, to create a safety net for future changes. If we do some modification on our code and all our code has tests, we know for sure that by introducing our new feature, we're not going to break anything, okay? Also, to document the code, this is like really important for me because I've changed my mind with with time. So at first I was like a really a strong opinion about, yeah, I want my code to have comments, but afterwards you get to see that some comments, usually like 99% of the time, when you run into a code that it's not yours, into a legacy code, some comments are outdated. So people have changed the code, have changed the functionality, but have forgotten to change the comment about what that function or procedure or whatever is doing, okay? So basically by doing TDD and stating in the tests what your program is meant to do, it's like the best way of documenting your code, because you know it's going to be updated, because if it's not updated, tests are going to fail. And also you have to, this will take a look after, but do a really good naming of the tests. And that's one of my other my other things, naming. Okay, so bear in mind that naming is really important. And also to discover how to implement complex functionality by building it up bit by bit. So it's basically doing baby steps. Okay, so instead of it allows us to get like to start, okay, let's start with this little thing and then move on to this little thing and go baby steps. The key of TDD basically is baby steps. We do not want to go like 3 steps further. We want to do step by step, little baby steps, okay? Even though it might seem like counterproductive, on the medium long term, we find that it's really productive because we have like all our code tested. Any questions so far? Or comments or doubts? Nope. Okay. Someone was going to say something? No? I've heard something? No? Okay.
I just said no.
Oh.
Sorry.
Oh, okay. Okay, no worries.
Now I can say something funny that happened to me last week. We was discussing with a colleague.
Tell us.
The name of, I mean, I had written a test, and the name of the test was long. It was like a sentence. I mean, it was, for me, it was auto-explanatory. And she went like, okay, I mean, there's a limit on that. And we were, I mean, I found it funny because, yeah, what you said, I mean, if the name of the test is self-explanatory, then you don't have to add anything else to it, because then you read it, and I mean, who cares if it's long?
Yeah. I mean, I do.
Yes.
Yeah, I totally agree with you. I'd rather, I mean, there are people that think otherwise, but based on what I've seen at my experience, I'd rather have a really long test name than, for example, I don't know, I'd rather have a test. Imagine that we're doing a calculator that says, when I add 2 plus 2, it should return 4. I'd rather have that test name than a test name that says adds. Because adds what? I mean, I don't know. I don't know what's add. What is adding for you? Maybe we're different. I mean, add it's like a simple thing that we all understand, but maybe some more complex. So I'd rather say exactly as a sentence what the test is doing and what their inputs are and what I expect their output to be. Because that's the way, if I am new to the code, that's the way I know what the code is doing, and you can document your code, live document your code by explaining really well what it's doing. So you go ahead with the long testing name. I support you, Paula. Okay, so pairing and TDD. For those of you who were in the first workshop of pairing and TDD, if you remember, we talked about a pairing practice called ping pong. So basically, ping pong is a pairing practice that works really, really well with TDD, because basically what it works like this. So imagine I'm pairing with Flor. So I write a failing test. And then what Flor has to do is write the code that makes the test pass and write the next failing test. And then what I have to do is make the test pass and refactor if needed without breaking any test. Okay, so instead of, if you remember, we talked about the driver navigator, which was the driver was the one holding the keyboard and typing and implementing, and the navigator was kind of a GPS telling the driver where they should go, what they should do next, etc. And this is another technique. It's the ping pong, and it's that you kind of both are the driver at the same time. Okay. So let's go with test structure. I think that you all know what the test structure should look like, but it's true that I've encountered sometimes some tests that are also difficult to read at some points. So I would divide the test in three different parts. The first one, that it's the arrange. So if we kind of read it in the cucumber language, it would be the given. Second, it's the act, that it's when. And 3, it's the assert, that it's then. So given whatever, when I do something, then something should happen. Okay. So for example, it's also called 3As. Some people use another terminology, but for me, this is like really simple. You have arrange, act, and assert. So imagine we have this example here. So should add s when word is normal. Okay, so we have our arrange, that it's going to be the new instantiation of the pluralizer object. Then we have the action, that it's actually calling the method pluralize with the word cat. And then we have the assert, that it's assert that our result is actually what we expect it to be. Okay. Any questions so far? No? Okay, so let's do a tiny mini example of TDD. I'm going to go in here. Okay, so imagine I have this blank project. So let's say it's going to be, the calculator that we were mentioning before, just to make it easy. Okay, so what's the first thing that you think I have to do? I'm using TDD.
Create a file.
Test class.
What, sorry?
Create a test class, a test file.
Test file. We all agree that the first thing we have to do is create the test file. Yep.
Yes. Yeah.
Nope. Some different opinions. Go
Yes,
ahead.
but no.
This is a safe space. Just talk.
Define the test first before start programming.
Mm-hmm.
But
sorry, I didn't understand you.
Sorry. Oh, first define the test. What do you want the tests to be?
Okay, so we can start by doing a new folder, well, package. Let's call it test. And we're going to create a new Java. This is in Java, sorry. Let's call calculator test. Do you agree that this should be our first step?
Yes.
Okay.
Yep.
Any other thoughts?
And if you want to run it, you would need a main somewhere.
I'm not very experienced in Java, but then, I mean, how are you going to run this then afterwards? So is there a test suite or just prepare whatever infrastructure you need to, or the IDE does it for you? I don't know. Because okay, in C++ you would have to do it. Maybe this is just click and then it.
Yep. So first of all, imagine you were talking about infrastructure, but I don't know what infrastructure. Imagine that this calculator, we are doing now a calculator. And we also, one of the requirements is that the calculator should store all the results in database, for example. So would you rather implement now the database?
I mean, I don't know whether you need a file to explicitly say to compile. I mean, you have to compile it and create a target out of this.
I see.
I mean,
yeah. So I think I understand you. So by creating, at least in IntelliJ, by creating this test and writing it, so semi-automatically imports you all the libraries that you might need and all that stuff. So you really do not have to worry too much about that.
Okay.
Thanks. Wonderful. Sorry, I didn't understood you at first. Sorry.
Okay.
So, okay, let's see. Let's say this. We have our calculator. Okay. So what's the first thing that you think we should do now? So it's not the first, it's like the second thing, but anyway.
I think something that we'll have to define either at some point is what type of test we want to write, if it's a unit test or an end-to-end test, I guess.
That's a really good question, because I forgot to mention. So some people said that TDD only works for unit test, but actually you can do TDD for unit test, integration test, or whatever. So, I mean, TDD is not only for unit test, okay? It's just defining the test before implementing the code. You can do the same for integration test. I mean, imagine the example that I thought that Paula mentioned before. If I want to store all the results of my calculator in a database, so I can start by doing unit tests now, and then I can do an integration test, but it's also doing TDD that says, when I calculate the addition of two numbers, it should store it in a database. By that naming of the test, you think that it should be an integration test, right? Because I'm involving, for example, also the database, but I'm writing first the test. So I'm doing TDD. Okay, so do not believe the people that say that TDD is only for unit test. Okay, so sorry, I missed what you said. Sorry, I totally forgot. What did you say again? Sorry.
No, I said, I guess we'll have to define what type of test. Here I assume we're doing unit tests, but I'm not sure.
Yep. So I recommend, because of what we said before, to start like baby steps, really baby steps. So for me, the first baby step is doing unit test. We will talk about later about all the different types of tests, or some different types of tests. But basically, I want to say this now in advance. Do not think that unit tests, it's referring to, I'm sorry, class equals to unit. I mean, by unit test, I'm not saying I'm testing this class. So basically the term unit test is a very, it's mangled, and some it has like different meanings for each person. But basically, when we are in a team, within the team, we decide what our unit we want to be. Okay, so maybe unit test, it's not just this class, it's maybe a little bit bigger. Okay, so yeah, we're starting now by doing, for example, unit tests at Flor, I think it was said. I'm sorry, I cannot see who's talking, but I'm going to assume it was Flor. Sorry if it wasn't you.
Yeah,
okay. It was you. Okay, cool. Because I have like the two screens and I'm like, I feel like kind of a DJ now because I don't know where to look. Okay, so let's see. I like, and also in Java 11, it allows you to do this. To say, okay, I'm going to write at test. And see, Paula IntelliJ is like really smart. And it allows you, okay, so I've detected that this might seem like a test, so let me help you. Now it's not going to help me. Add test. Okay, so I want to add this one, this JUnit library. Yep. Okay, so now we have this. We're doing a calculator and we want for now the calculator to do additions, just only additions. So what is the first test that you would write?
Normally I want to start with a test that only create an instance of the calculate and test that the instance is create correctly.
Okay.
Normally I beginning with a test.
So you would say, imagine that now we are doing mock programming. You tell me what to write. So public void, and you would say something like should create calculator instance correctly, for example.
Yes.
Okay. And what would happen here? Let me, sorry. I have here the arrange part. I have here the act part, and I have here the assert part. So what would we put in the arrange?
I think that the instance of the declaration of the instance of the bar is better to do it's better to do out of this test to share it with all the tests. No,
Okay. Okay.
The arrange.
Do you think that maybe that's going a step too far? Because we don't know if we are going to need the instance of the calculator in further tests.
Okay, perfect.
Okay, so this is what I mean. The first time I did TDD, I want to do those things. One, cry a lot, and two, kill my partner. Okay, so if you feel like your brain is going through your nose, that means that if you haven't done TDD first, we are in the right path. Okay, if you feel like your brain is melting and it's going to start coming out through your nose, then we are starting to do TDD. So maybe that's a step too far. Maybe do we need an instance of the calculator? I don't know. Maybe we could try. Okay, so maybe what we could do here is calculator equals new calculator, blah, blah. So what would be our act? Maybe our act and our arrange is the same?
No, I put in the arrange, I only put the declaration of variable.
Okay.
In the act, the instance, the create the instance. Yes.
Okay. Calculator equals new calculator, blah, blah. And what would we put in the assert?
It's not known.
Okay, so assert. I think that here we can, let me put first the assert equals so I can import this. Import the static method. I think it is or assertion assert equals. I think it's this one of assertions. Yep. Okay. So let me put here. I'm going to put. I do not recommend to put the asterisk, but it's just because I don't know whether if it's assert not equals, I think it is called, not equals. Oh, equals.
Is no as because I don't remember Java assert not null or undefined or something like that.
Maybe.
Because in jest you can do like a expect not to be undefined or something like that.
Yeah. So let's do assert all, assert equals.
In Java you have assert that, and then you can do
assert does not throw, assert equals, assert equals. Shit, too many assert equals. Assert not equals. Assert not equals, but it's only assert not equals, assert not equals, assert not equals. Let's see, we have something like assert not tool. Ah, here it is. Assert not tool. Calculator. What's going on? Required object. Ah, okay. So we cannot do this. Okay, so we have to look for another assert. Assert not null. Let's start with the assert not equals, because to be honest, I haven't used that much the assert not equals. Okay. Assert not equals. And I think that in Java is null and then unexpected. What's going on here? Cannot resolve method. What's happening? Cannot resolve method. Why not? Create method assert not equals. Create method assert not equals, but I do not want this. I'm doing this one. Why won't you let me do the assert not equals?
Very strange, I think.
Yep.
Well, maybe it's just because the object doesn't exist and it doesn't, or
Would be.
can you do assert not equal 1, 3?
See, let's try. 1.
Maybe because the calculator type is not defined.
Yep, that's it.
That's what I guess. Yeah.
Okay, so null and calculator. Okay, so basically we have, if we want to now run our test, it would say that obviously the tests are not going to pass. Hide floating meeting controls. I don't know. Okay. So now what we are going to do is to create class calculator. Destination. No, let me create the folder here. Main. Okay, now create class calculator, and I want to create it in main. Okay, okay, okay. Now I have the calculator. Okay, okay. So let's run
Maybe
this.
you can also now check whether assert not null also works, because it might work now.
Yep. Okay. So now this test work, but it doesn't seem that like we are testing that much, right? In this test, we are just asserting that our object is created. Do you think that this test really apports some value to us, or maybe we do not have any need for this test?
Paula,
yeah.
Just one point. Can you test use assert not null? Just to verify it now. It will work.
Sure. Sure.
Okay. Yes.
So let's try. Let's comment this and say assert not null calculator.
Okay.
Run. Cool. Cool. Okay, so do you think that this test adds any value to us? I mean, I'm not doubting it. I'm just trying to open a conversation about it.
I would have started with the add, like something like you say, like should add 2 and 3, should return 4, something like that.
Okay, so let's do something like this. Terminal. I don't know whether if I have it on Git, this thing. I don't think so. Oh, I do. Git stash. Okay. Okay, so maybe what I think it was Sendami was saying is that we should, no, new project, no, sorry. Example, new module, SRC. Oh, what am I doing? SRC, and now here we have test. And now here we have the Java class calculator test. Add again, add test, import class. Okay. And then we would have public void. And what would you name it, Sendami?
Sorry, I'm very bad with names, but like I don't know.
Name it as long as you want. Remember that this is the documentation of our code.
I don't know, it could be like 1 + 1 should return 2, something like that. I don't know.
Okay, so maybe something like when adding 1 + 1, it should return 2.
Yeah, something like that.
Cool. So this is what Paula was mentioning before. So do you think that this naming of the method is too long? Because for me, I'd rather have naming of the method like this that just says addition. Addition what? What is addition? What do you mean by addition? Okay, so I'd rather have this because if I'm new to this code, I mean, this is a calculator and it's simple. But if I'm new to this code and I go, okay, so when I run into a code that I've never worked before, what I do first is go to the tests. Because that's like a really simple, if they are done correctly, a really simple and easy way for me to know how the application works, okay? So I know that, for example, in here, when adding 1 + 1, it should return 2. Okay, so I should have here the Serrano, no, arrange. I should have here the act, and I should have here the assert. Okay, so what would we put in the assert, Sendami? I'm sorry, in the arrange. Sorry.
In the arrange, perhaps create the class.
Okay, calculator equals new calculator. Okay, anything else?
No.
Do you think that maybe in the arrange we could do this?
And create the
Int
variables.
first, that's right. I don't know who
Okay.
was.
I was going to
it?
put it just like 2 and 2.
Like right values.
Yep. Was it you, Paula? The one who
Yeah.
was speaking? I'm sorry, because I cannot see. Let me change the view
Okay.
to see if
Doesn't
at least.
matter.
Okay. Okay, so maybe first variable equals 1 and int. Even though if we are adding 1 + 1 and they are both 1, I would
Maybe we have
do.
to specify their integers in the title as well.
What do you mean? Sorry?
Because I mean, I guess you will have to do a function. Well, you don't have, you would have to do a function to add floats, you would have to do a function to add integers maybe, or you just generalize everything and do it for floats. I mean, the add
so
function.
Now, yeah, sorry.
Or we do it for floats only.
So maybe, because do you think that maybe that's thinking two way in advance? Maybe we could start that with, I know that this is like counterintuitive. So if you at this moment want to kill me, I understand you. I do totally understand
Then
you.
Okay, we can think in, and then I would do floats instead of int. That would be my, but I don't know if it's also thinking in advance, but it's
Okay,
like
so
with floats, everything's gonna work no matter what you add.
Okay.
That's why I would go for floats, but I don't know.
Do you think that maybe it should be a good approach to first do the test for the integers, then do the test for the floats, and if we see something going on, maybe we can refactor?
Okay, that's
cool. Okay, so we have this calculator that is going to do this. Sendame, what would be the act?
I will add as well the expected result. So as we have the input values.
Okay, so you put here int result.
Yeah.
Okay.
But with equal to, because we already know. No?
Okay,
that should return true.
So the result, you mean like expected result. Cool. Okay, so what should we put in the act? What do you think?
So sorry, so the expected result I will add like is equal to.
Oh, sorry,
because
yes.
we know.
Yes.
Yeah.
Agree,
and then maybe another variable for the result.
For the result itself, okay. Int actual result. Am I dyslexic? I always have to write the words twice because the first time I always write them wrong. Okay. What should we do here?
Well, it will be calculator that add or something like that.
Calculator dot add. Okay.
With the first variable and second variable.
First variable, second variable,
and I suppose we should result. Yeah.
Okay, cool. So now we have this, and what should we do in the assert?
It would be the assert equal that you.
Okay, assert equals.
Are equals.
I can't remember whether if it's assert equals create logger, create field. I don't know what it won't let me. Let me just finish writing assert equals expected result with the actual result. So import. Cool. Assertion. Okay. I think what's going on? Create method assert equals. I do not need it. Okay, so this is going to fail, right?
I hope so.
I can run it, but I think that we can all agree that.
Imagine that putting green.
Yeah, yeah. I mean, if this pass, I will just close my computer and go. Okay, this weekend has ended for me.
Yes.
My work is useless. Okay, so let's do the package. I'm sorry. Yeah, the package I have to do. And now if this is smart enough, it would allow me to create it in main. Okay. Add. Because I'm putting all this in capitals. I mess these things because today this week I've been doing functional programming and it was in capital. I have every language is totally different. Don't longer know which is in capital letters and which is in no. Okay, so even though we've now created the calculator, we are going to run this test and it's still going to fail. Cool. Why? Because we do not have the add method. Create method. Add. Okay. See, IntelliJ is awesome for this because it takes you away a lot of time. Okay, so basically, what would this do? Send me.
Return 2.
Nice, nice. Okay, so remember, we had to do the minimal amount of code to make the test pass. This is the minimal amount of code. So this is what we were mentioning about baby steps. So I think that what I would have done previously would be return first variable plus second variable, blah, blah. No, this is not the minimum code to make the test pass, okay? So please believe me that this is really useful, okay?
Because this is simple, but when you have like a complex function or something that's complex, it's impossible to do this on the first like in one line.
That's it. That's it. So this because calculator is really easy, but as Gabby said, when systems get complex, it's really when we say return make the minimum amount of code to make the test pass, we do really mean make the minimum amount of code to make the test pass. Remember what we talked about, the KEYS principle, keep it simple, stupid. Keep it simple, comma, stupid. So this is KEYS. This is keeping it simple. Okay. So return to. Okay. So let's run. Cool. So this has passed. So
let's go home.
that's it. That's it. That's all for the weekend, women. See you next Saturday.
Yeah.
Okay. So what would do you think we should do? We should do next.
That's where I'm finding a problem when I use TDD, because for now I don't know if then it's refactor, right? So the next step, it will be refactor or something like that.
Okay. It will be another addition,
right,
so that
yeah.
we have to write
the
method correctly or accommodate. Well, if we do 0 plus 2, then we won't.
Okay, so
but I don't think whose return is different from 2.
So maybe do you think that because this is now what works? I mean, if we had to deploy this to production, we know that this works because it's what it's going to do. But when we say adding 2 plus 2, it should return 4. So first variable 2, second variable 2, expected result 4, and this is really important to not only execute the test that you have just written, okay? Execute all of them to see if we have with our changes, I mean, obviously now we haven't done any changes, but to see if with our changes something has broken, okay? Okay, so yes, now this is not working. So maybe what we should do is do the refactor now. So maybe our natural refactor now would be this one. First variable plus second variable. Whoops.
Funnily enough, we could do 2 times first variable and then it will work.
Yeah, that's right.
But okay.
But let's assume that we that we are just like kindergartens and we're going to, okay, but let's go step by step. So this is what I was mentioning before, that TDD, we have to do baby steps, and it might be a bit frustrating because we as programmers, we tend to overthink, and just like when we hear a problem, we start like doing in our heads all the things that we should done and just like create the diagram in our heads, and we start to see all the flows and all the maths and all the equation and all the things, like the meme that the guy is just like seeing equations all over the place. But we really have to do baby steps, okay? Because if we do not do baby steps, we might be missing something, and it could lead to a potential bug. Okay, so now it seems that both our tests are passing. Okay, this one and this
Paola, really
Yep.
to be purist, I don't know in English.
Yep.
To be purist, the minimum code that make the two tests passed is not that you write it. It's first argument multiply 2.
Yeah, but okay, that's,
Yep.
that's what I thought anyway.
Okay.
First variable multiply 2.
Okay, yeah, so this is because I've chosen like
Yes.
some really mean, maybe this wasn't like a really good choice of arguments. Let's put 3. Let's put 3.
Yeah, yes.
3, 2, 3, and it should return 5. 5. Okay, does this still pass? Let's see. So I know that in some, I don't have it configured here, but I know that I don't know whether it fits. I think it's at either level. So for example, in IntelliJ, you can configure like, I don't know the exact name, but it's something like test watch. So it automatically detects when you have made a change. So every time you made a change, it would automatically run the tests again. Okay, so instead of me having to click in the play, you have to, at least I've seen it in JavaScript, but I don't think that it's just of the library we were using. I think that it's of the IntelliJ. Okay, so this, it seems like now it should work. Okay. So
sorry, Paola, one question.
Yeah.
So it would be like so when the first test pass, the next step is create another test, right? Add more tests. So
yeah, I would
keep testing the functionality that we were given.
Yep. So because now we are starting, and maybe it's a bit confusing. So you could do the refactor, but to be honest, if we just have the first step, and what do we have to refactor? Because at this moment, our calculator only does one thing, right? So we do not have much to refactor. We just have the return to. So if we add the test, we then see the necessity of the refactoring. And that's why after we add the second test and we see it turning red, then we start to do the refactor and run again all the tests. So we are aware that we haven't broken anything.
Okay.
At least that's what I used to do, because I really like to do everything in baby steps, because I tend to forget a lot of things, and to be honest, my mind goes all over the place. So I'd rather do really baby steps. I remember previously that I was like, when I faced that problem, I was kind of overwhelmed of how I should do things or what I should do things. And to be honest, after the first days of trying to kill my partner, because he would literally just hit me in the hands when I was doing more code that I was meant to be, you get to realize that, to be honest, life is easier when you do baby steps, because you don't have that angst and that feeling that maybe you're gonna break something or whatever. You just, it's also like you get to a state of mind, kind of like a mindfulness, because you are doing the test first and you are kind of trying to cover all the possible things. Obviously, there are always going to be some corner cases that you are missing because nobody is perfect. But yeah, it kind of gives you that peace of mind.
One question. So because this is so simple, but imagine that you're writing a new class that is being used in something else that was already created, and then you are refactoring something, whatever. But for example, in using Jest, you cannot execute the test because it's not compiling. It's just not compiling. What do you do in the other class? So you work to have the other class working, or you just comment the code? Because it's just yesterday I found that this problem because I didn't know what I should do. Should I fix that? But then it's not a BB step because I'm doing something else.
So just to make sure I understand. So you had already a class created that had tests, And then you wanted to add another class?
Yes, so imagine that in that class that you're already existing, I'm refactoring one method. Okay, well, not that method, I call to a class that has a method. But I assign refactoring, this class stopped working because I added more arguments or
but
the parent class, let's say.
Yep. So what I would do is I would first add the test of the new method signature that has the new method signature because you are adding more arguments. And obviously that test is going to fail. Not the rest because you haven't yet modified the test, the method itself, but yes, the test. So when you have that test failing, no, sorry. I totally misunderstood you.
No, yeah, that's the thing.
So first, when you have all your tests running, you should change the signature method because you have like your safety net that it's working. So with this new signature, this new method signature, were the previous tests going to change, or was it says that, let me for example, that the new argument of the method is optional?
Okay, I get you. Yeah, so that's a problem that the parent class doesn't have tests. Yeah. So.
Yeah. Yep. So if you want to change something on some class or whatever that already has tests, do the refactor and then run the test again, because that test suite is your safety net that you aren't breaking anything. Okay, that's at least what I would do. Let me think it again.
The problem is that when you are working with legacy code and things like that,
that's we're going to see it later on, how to work with legacy code.
Okay,
because what we understand as legacy code is some code that doesn't have any test. So, which has never happened to any one of us who has run into a code that hasn't got tests. Never. So yeah, that's there's a method that you can use when you have legacy code and combine the method that I'm going to talk to you later on with TDD. So at least you are making sure that you are not breaking anything of what is already done, but the new functionality you are using TDD. Okay?
Cool. Yeah.
Cool. Okay. So I don't know what time is it. I don't know where am I. I don't know how many time I have left. Let me check the slides. Okay, we were here. Okay, cool. Yes. What time is it? 11:30. Okay, maybe we can do until 11 and do a little break. Okay, so as we've seen, this is like a really easy example of TDD. But now we're going to see test doubles. Has any one of you heard about test doubles?
No.
Okay. So I like to think as test doubles like, do you know the films? Well, not Tom Cruise, because Tom Cruise, like, he says that he does all his action scenes. But do you know there are like action actors that do some, let's say, risky sequences in the films so that the actor doesn't have to do them? So that's what, more or less, that's the concept of test doubles, okay? So instead of using the objects themselves that we might need to use, we create a double so that we don't involve the other objects or whatever that we might need. Okay?
It's the mock or not? It's the same concept?
Yeah, so mock actually is one type of test doubles. So we have 5 types of test doubles. We have dummy, fake, stab, spy, and mock. So let's go one by one. I'm going to go through all of these and then we're going to see one example of each, okay? So basically, dummy are objects that are passed around but are never used. They are just to add as an arguments to the function, okay? So that the method signature is coherent. Then we have the fake, that it's objects that have actually that have working implementation, but usually take some shortcut. So like the common example of this is like what we were talking previously about the calculator, that after doing the addition, I want to store them in a database. Okay, so if I don't want to use the database, I would create an in-memory database, which can be an array or whatever, that mimics the thing that would happen to an actually database, but I'm not calling the database. Then we have the stub that provides canned answers to calls made during the test for a specific input, but that's all it does. Then we have the spy, that it's kind of a stub, but also recall information about how methods were called. And then we have mock, that it's pre-programmed with expectations which form a specification of the calls they are expected to receive. So basically, I would separate these 5 test doubles in dummies, fake, and stubs in one group, and spies and mock in the other group. Why? Because dummies, fake, and stubs usually verify the state of objects, and spies and mock usually verify the behavior of the objects. Okay, so let's go into see some examples of this. IntelliJ. File, open, and let's open desktop, Thoughtworks, WomanUp, examples, TDD, and dummies. Okay.
Paula,
Yep.
Can you repeat? You said mock and spy, it's regarding to the behavior, and the first 3?
To the state of the object. Yep.
Ah, okay, thank you.
Yep. So dummy, fake, and stubs usually verify the state of the object, and spies and mock the behavior. So we're going to, I think that you will see it clearer in the examples. If after we've seen the examples you still don't see it, feel free to ask and to say, hey, I still don't understand it, because that's what we are here for. Okay, so let's go to IntelliJ. Okay, so we imagine we have this school. So we have a class that is a school class, and it has a name, an array list of students that are enrolled to that class. So we have here the constructor, add the student to class, and number of students. Then we have the students, the student that has name, surname, and age. And now we have our class test. So our first method could be should add new student to class. So should add new student to class, it's testing this method, right? The add a student to a school class. But as you can see, to call this method, we need a student. Okay, so maybe, I don't know. Let's create this dummy student. Okay, because a student is a really easy class to create, but maybe there are some really complex classes. So instead of instantiating and creating a really complex class that may depend on other class and blah, 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 we can say, okay, I'm going to create the school class with the constructor of the school class itself, which was the name of the class and the array list of the students. Web. And now when I make the call to the add student to a school class, I'm passing a dummy student, because I'm just creating this dummy student to to comply with the signature of the method. That's it, because I don't want anything else. I don't care how it's called, what's the name of the student. I don't care about anything. I'm just creating this dummy student because I have to for this method, okay? So then what I'm going to do is I'm going to assert that the number of students of a school class is 1 because it's I've just added dummy student. Okay, so let's run this test. Cool. Okay, so I think it was Fabiana. So as you can see here, we are verifying the state of number of, I mean, of a school class number of students. What it's that it's getting us the size of the array. So we are actually verifying the state of the array of the school class. Okay, so we are asserting that we have only 1 student in this school class. Okay.
Okay.
Any doubt so far?
No, it's okay.
Okay. Any of you have any doubt or whatever?
No.
Nope. Okay. Okay, so let's go to the next one. Next one, we have the fake. Okay, so objects that actually have working implementations, but usually take some shortcut, which makes them not suitable for production. So what we mentioned, like the most common one is the one dealing with database. Okay, so let's open. Oh, no, not the whole desktop, please. File, open, desktop, Thoughtworks, WomanUp, examples, TDD, fake. Okay, let's open this example. Okay, so when it finished opening, okay, so now what we have the same student class, but now we have the student repository, which is an interface. So obviously, this interface is going to be implemented by whatever. And what we have here is, imagine that when we have a student, we are going to add the students to a database. Okay, so we have this interface that is going to be implemented by whatever that it's going to store the objects in a database. But maybe that is more kind of an integration test. Maybe the scope it's too big for us at this moment. Okay, so what we do is we create a fake student repository that implements the same the same interface that the actual thing is going to implement. And what we are going to do, is like to mimic the same things that would happen with the database. So we have the add a student, that it's in here, and get a student. But instead of using a database, which we might need to, I don't know, to create a Docker and create all the infrastructure or whatever, we're just going to use an array. So what we do here in the student repository test is we create our student, we create our fake, is the new fake student repository. And what we're going to do is clear it. It's just to make sure that everything is empty. Okay, this is all part of the arrange. Then the act, we're going to add a student. So it's going to be the same as if we were doing usually, but we are going to we're going to do the fake student repository. So what we are going to do now is to assert that the size, it's 1, it's only 1. So we are mimicking here that we are that interaction with a potential database. Okay, so we are also here, we are asserting the state of an array in this case. Okay, any questions so far?
So what I see here, so I mean, I see this code and saying we are testing the fake. So it's kind of.
We are saying, okay, this test should add new students to repository. So actually what I'm testing here, because if you see a fake student repository is implementing the same thing as add a student.
The interface.
That's it. That's it.
Cool.
So because this is a really simple example, but if you have to do something with the database or whatever, because I mean, at the student at this moment is just doing something. But imagine that we have before having to add, we will have to do some verifications or whatever. So maybe this add method should be is more complex, but we do not want to have that actual interaction with the database, because that would take a lot of time, presumably more time, almost certain, that doing this little test, and we can substitute it by this in-memory thing. Okay.
Yeah.
Cool. Any other questions? No? Okay. So let's move to the next one. We have a stub. And it says that it provides canned answers to calls made during the test for a specific input. Okay, so let's see if that's true. File open. Desktop. Thoughtworks. WomanUp. Examples. TDD. Stub. Okay. So what we have here now, let me close everything. Close all tabs. Okay, so we still have the student, the same thing, but now when we enroll to a class, when the student enrolls to a class, apart from doing a lot of other stuff, it's going to send a confirmation message, okay, with the name of the class that this student has enrolled to. We still have the school class and we have the interface of mail service. Now we have the student test. So this is like because I didn't know which of these two tests would represent better or how would you understand better the spirit of the stub. So let's try with this one first, and if not, we'll try with this one. Hola, perrita. Sorry, my little dog just came to say hello. Okay, so let's try this message, which is send message to a student when successfully enrolled to class. So in our arrange, we're going to, instead of accessing directly to our mail service, because we don't want to send mails, or imagine that because I've seen this happening. We could, but not with mails, but with mobile phones. Imagine we are putting a random mobile phone, but that mobile phone is actually of someone. So when you do the test, when you are running the test, you just keep sending SMS to someone. And that is really annoying, okay? So instead of using the actually mail service, we're going to create a mail service stub that implements the mail service, and in send confirmation message, what we are going to do is just print this, okay? Message successfully sent. Okay, so what is our test going to do? We're going to create the mail service tab, the student, and the school class. And when we do the enroll, we are going to pass, if you see here, the enroll to class method had two inputs, the mail service itself and the school class. So we can access the name of the class that we actually enrolled to. So we're going to pass the stub and the school class. And what we are going to assert is that message successfully sent for class, this class, because it's what we said here, that the name of the class was going to be, is actually what the mail service stub sent, okay? Because we're going to say message successfully sent for class, whatever, and this whatever is this message, and the message is, the school class, okay? So let's run this. Cool. Okay. So with this, we have actually seen that we are sending a message. If bear in mind that we are dealing with at this moment not with integration test, because there's another type of test that's integration test, and we do actually also want to test that mails are effectively being sent. But for our purpose at the moment, we do not want that. First of all, because if we are starting, imagine this is our first iteration of the program, we do not have the need yet to create the mail service. We are doing TDD, and we are keeping it simple, and we are not implementing things that we are not needing it at the moment. So at this moment, I do not need a mail service because I'm not yet there. I'm on the baby step before. So I'm just creating a step to say, okay, at least the enroll to class method, it works because it actually calling to the mail service implementation, and we are doing the mail service step. Elisa.
Yes, I have a question.
Sure. Sorry, I cannot hear you. For some reason, your microphone went down or something.
Can you hear me now?
Now, okay.
Okay. I don't know why this is.
It was like, I have a question, and then
Yes.
and I was like, okay, cool. Sorry, it happened again.
It is something about I cannot. Oh, sorry.
No worries. Feel free to shout.
Something about the volume.
Yep.
It goes down and up.
Yep.
Now.
Yep.
I'm no. Okay. Okay. I'm going to.
She's going to do something.
I think she says she's going
to write it, maybe. Yes. Okay, let me open the chat then. On the meantime, do you have any other questions while Elisa writes her question? No? Please, if you have any doubt, ask.
If we could have a look again at the implementation of the fake, just to compare.
Sorry?
To have a look again at the fake implementation. So the previous one. Just to compare the two of them, because for me it's not.
The student, you say?
No, the fake implementation.
The fake. Sorry.
Yeah.
Let me see if
maybe
it's
somebody's going to ask about this.
Dummy fake.
Yeah. So the
Okay.
fake student, the class fake student repo.
Okay, the fake student repository.
I just wanted to read it again.
Yeah, sure.
Show it.
Sure. Okay, so we have the student repository, that it's an interface, and presumably to this interface, there are going to be some other components that are going to implement this interface in order to get to a database. So when I add a student to a, when I call the method add student, it's going to actually add a student to a database, but I don't have that database yet. Or I do, but I do not want to use it for the purpose of the test. I mean, you can be in this situation for two reasons. One, you don't want to use the database for whatever reason it is, maybe because it costs you money or it costs you time or whatever. Or maybe you are in this situation because you are doing TDD and you haven't yet implemented the database. So what you do is you create a fake that is acting as the database itself, but instead of being a database, it's an in-memory database, which is basically an array. I mean, this is like the most common use of fakes that you will see. that instead of accessing to a database, you just store what is going to be in the database is in an array or in a text or in a whatever. So what you do is you make sure that at a student it's being called, and you verify the state of a fake student repository, that in this case is the size of the array of fake student repository. Was that clear now? If no, I can give it another go.
Individually, I understand the two of them, but it's difficult for me to conceptually differentiate them somehow. I mean,
So between fake and what other? And stub. Okay.
Yeah, me too. I can see clearly the difference. Because stub is like fake, really.
So stub is like it's like fake. Let me see if I can explain myself better. Okay, so so in fake we have objects that actually have working implementations because we are actually adding something. But a stub, what do is provides canned answers to the calls we have made. So let's see again.
In one case, you have like the list that is kind of substituting the database. So your solution in the fake to the storage is your list, whereas in the stub you have nothing but a message being sent or something like that.
Yep. So in the fake, sorry, let me go again to the fake.
In the fake, replacing the database or the behavior.
That's it. That's it. In the fake, we are replacing the database, but this fake student repository, that in our case, it's an array. And in the stub, what we are doing is providing this canned answer. I mean, I know that all the times I call this method, this is going to be the same. I mean, I'm going to provide this answer always. I mean, the only thing that is going to vary is this message, but because this is the input of the method, but I'm always going to provide this answer. So later on, I can, on the test, I'm going to assert that the answer that I received from the stub, that the provided can answer of the stub, it's what I want it to be. Does that make it clearer?
Okay, aren't we faking the mail service class with the interface?
I mean, you are always faking because all these are test doubles. So you are always faking the actual thing. I mean, you are always doubling the thing. The main difference is what do you replace them for and how do they work? So you're always replacing the actual thing by something, but on the fake, it's just you have working implementations because you are actually adding things to something that in our case is adding students to a list, blah, 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 here. So we're actually doing something. We're actually adding students to a list, and we are when we get student by name, we're actually forgot the word for recorrer, going through the list to get the name. But in the stub, we are doing absolutely nothing except providing this answer. That's all we are doing.
The stub you call the real class, right?
In the stub, in the stub, we are also creating a new class. So we have an interface that it's going to implement our actual messaging service, maybe whatever it is, Gmail or whatever, but we are creating a stub that it's also implementing that interface. But what it's going to do is just provide a canned answer, just that. It's not going to do anything else.
In both cases, I have to create like a other class to overplace the real class. But
That's
this
it.
kind
Also
of test...
in the dummy, in the dummy you do also, if you remember, we also created a dummy student. But what we do is just extend it for the student itself and just initialize everything to null. This is a really simple example, but maybe if dummy student, if a student, instead of being strings and integers, would also have classes and classes and classes and classes, maybe it's a bit hard, imagine, because in our example of the dummy, we only wanted the student, so we could fulfill the add student to school class method signature. But imagine that student have a string, and then 3 different classes, I don't know, whatever. So we do not want to create all those classes. We do not want just to be able to pass a student as an attribute to fulfill the method signature. We do not want to have to create 7 other classes. We just instantiate everything to null. We just say, okay, dummy student, everything to null, and I pass it to the method, and that's it.
And how trust will be this test, because we are not using real classes? How can I give some guarantees that it will cover the real class scenarios?
You are actually calling the class, because what in this test we are testing is that a new student is added to the class. So I am actually asserting that the add student to a school class is working. I mean, this is a really simple method. We only are doing the add to the list, but imagine the add to a student to a school class does a lot more things. And this is actually what I'm testing. This is my testing method. The only thing is that in order to be able to test this method, I have to pass a dummy student. I mean, I have to pass a student, but I do not want to create a student. In this case, it's really simple because it's only 2 strings and 1 integer. But if it's like a really big object that depends on other objects and depends in another object, you do not want you do not want to create all those objects and objects and objects. You just create a dummy, so you can pass it in the method signature so that the method actually works. But I do not care about the values of this. What I want to do is, okay, I want to make sure that this method works. And how do I know that this method works? Because I'm going to assert that the number of students is 1. I just want to make sure that it has added our student, not the values of the student. I do not care about that at all.
Because in this case, the focus is Q class. It's the real class, right?
Yeah.
But in the fake class that overplays the database, how can I trust on this? In that scenario you said before, when do you send the data that will be inserted in the database, have some validation, something like that?
So because this is like a really simple example. So when we add a student, we really do not do much at all. And maybe we want to do this because at this moment, we do not know whether if our persistent system is going to be a database, like SQL and Elastic. We don't know. We haven't got there yet. We don't know what's going to be. So I just want to make sure that when I add a student, or that this method add student actually does something. So we can be here because of 2 things, because we haven't got there yet and we do not know what our persistence is going to be like. Or we can be here because we want to have a test that it's not an integration test, because what you are talking about is actually an integration test. So on an integration test, we actually can use that database because we do want to know that mails are sent, and we want to know that actually the data is being stored in a database. Of course, we do have to have that tests, but rather we haven't arrived at yet, or we want to make a previous test that runs fast, and we do not need to actually store something in the database because it might take a lot more time.
Okay. Can you hear me now?
Yes, Elisa.
Okay. It was something about the Zoom
No worries.
Configuration. Yeah.
No worries.
Yeah, this is my question is somehow related to this because I would like to understand or would like to know in this whole process. I understand that you have some tests that you can keep it as they are, like this double test, but I understand that at some point you need to change those fakes by the proper one. So how do you manage this? Do you finish the whole unit test and then start the integration like a second step, or how you manage this and yes, keep the track that all the tests that you have to change into real or not fake ones?
Yep.
And yeah, that's sort of my question, this process, how you manage this.
Yep. So I would for sure keep these ones because the risk of removing tests is that if you remove a test and you change something, then you might be missing a bug. So if we are, I mean, this is just like a little example, but obviously this can grow and we might want to make a web for a university. So we do actually want to store, we want to have persistence of our students and what class they are enrolled to and all that stuff. So we can start by creating this to make sure that our code at this time, because remember we are doing baby steps, is going to work. But later on we can create integration tests. And of course we can make the actual call to the actual database. But just leave this here because it takes nothing to execute and you have that safety net that you are not breaking anything. Imagine that on the future, because usually integration tests are not run that much. I mean, the spirit also of TDD and using it in unit tests is that you can run them like whenever you want and they are fast. So every time I touch something, I can run them again. That doesn't happen with an integration test. They take long. So if tests take long, what usually happens is that programmers avoid executing tests because they go like, oh, this is going to take so long, so I'm not going to execute them because it might take like 15 minutes to execute a test. So I'm not going to do that. So this is like the spirit of doing these things, because we do not want to test the whole system. We just want to test this little part, and we want to take to test it fast. Too many T's in that sentence. To test it fast. So we substitute the actual thing for a test double that serve our purpose, but of course, on the future, we can have an integration test that actually does all the thing. But do not remove this test. Even if you feel it's duplicated, I personally, I would rather have too many tests than having less tests and risking introducing a bug somewhere.
Yeah, the problem is that, for example, in my case, I program in Node.js and I have continuous integration and continuous deployment. And one of the job is the testing. So when you want to deploy something to production, you need to wait a long time to do that.
So imagine that. That's it. When you want to deploy something to production, when you are doing continuous integration, if some of you do not know what continuous integration is, it's basically that we are all working in the same master or main branch or whatever you want to call it. We might have short-lived branches, but basically what we do is every commit, it goes to our main base. So we are all sharing the same things. So that's one of the reasons what I do also imagine that because I want to make small commits to this main branch or master or develop or whatever you want to call it. So I want to make sure that I haven't broken anything that could potentially affect my teammates when they do the pull of my changes. So one of the solutions that I might have is, okay, I'm going to introduce this test double, for example, here, the fake test double, to at least see that I haven't break the add student. Again, this is a really simple example, but that I haven't broken this method. And that even though if we are not actually storing the data in the database itself, that we are just using an in-memory database, which in our case is an array, sorry, the method is still working. So that way you do usually have the confidence that your tests work. Usually, even though if the pipeline is well built, it wouldn't allow you to make a commit into master if the tests are broken. I usually also want to run the tests myself previously, because sometimes I've been in cases where you have like before pushing to master or to whatever, you have several hooks, several GitHub hooks and wherever, and to push it takes forever. So I just want to be able to click play and be certain that I haven't broken anything of the code. Does that answer your question?
Yes, yes. Yes, somehow, yes.
If it hasn't, just please let me know, because I tend to divagate a lot and maybe I wasn't concise enough.
Yeah, I am just thinking that maybe you have a branch in order to execute all the testing and in local, or
no, you can just do it in the same branch. I mean, the good thing about this, if you combine it, doesn't matter, because how many people are touching, let's say, the same part of code, that we are making sure that we aren't breaking anything, because I've got all the tests and we all have got all the tests and we are all responsible of not breaking anything. So I'm going to say, okay, every little piece of code that I'm introduced is going to be tested. In this case, I do not want to access the database for whatever reason it is, but I do actually want to make sure that my add student method, imagine, because here add student is just adding things, but it could do here a lot of other stuff, like verifications or whatever. And I do actually want to make sure that that works. Okay, so I want to make sure that that this add student method is still working, but I do not want to store more things on the database, because if I store more things in the database, maybe it's going to cost me more. Maybe it's going to charge us more, because I'm going to consume more time, because I'm going to consume more memory, because then later I have to have the time and remember that I have to delete the data from the database that I used for tests. In our case, in integration test, when we see later on integration test, you do actually have to use the real thing.
Okay, thank you.
Okay, no worries. Any other question? I don't know whether if there was a raised hand before. I can't remember. No? Okay. So this we have seen the dummy, the fake, and the stub. These ones tested the state of things. And now we're going to see the spy and the mocks. So let's go with the spies. Open. Desktop. Thoughtworks, WomanUp, examples, TDD. Where were we? In the mock. Okay. Okay, so let's see again what it says for mock. I'm sorry, well, we'll see first the mock, doesn't matter. So it's pre-programmed with expectations which form a specification of the calls that they are expected to receive. Okay, let's see how this works. Plop, 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 plop. Let me close everything, close all tabs. Main and test. Okay, we still have the student, we still have the school class, and now we have the school admin. Okay, so we have the interface, school admin, And one, or at least by now, its responsibility is to shut down the school due to a fire. Imagine that I have a fire in the chemistry laboratory and I want to shut the windows and the door so that fire won't spread. Okay, so I've got here my implementation of the actual school admin and my method. Okay, so let's see this test. Send message to students. No, this test is wrongly. This test should be, let's see, what should the test be named? Maybe something like should close lab windows when a fire declared. Something like this, a meaningful name test. Okay, so we're going to see two different ways of doing the mocks and the spies. So one that it's not commonly used, but I want to let you know how, because the other one is using a framework, so a library, sorry, Mockito, but I want to let you know how it actually works on the inside, but you do not have to do this, and it's better to use the Mockito library. Okay, so we have the school admin mock. So it has like a lot of things. Again, you don't have to like remember this thing because it's better to use the library. But what we're going to do is we have a method that is called register called, invocation, the arguments, and the shut school due to a fire method itself. Also, we have a class that is called method invocation and has these methods. Not use. Okay, so in the arrange, we are going to create the school mock. We are going to create the student, the school class, and whatever. Okay, maybe we do not need this. Ah! Erase too much. This thing. Do not need this. Okay. So what I want to test is the shut school due to a fire. So I want the admin mock to do the shut school due to a fire. But I do not want that every time I run this test, I actually shut the windows and the doors of the lab of chemistry. Because imagine that I'm running this test, like every time I make a change in my code, I am running this test and I am actually closing all the windows and the doors of the chemistry lab. I mean, Iker Jimenez could go there to see what's happening and why windows and doors are opening and close every 5 milliseconds. Okay, so I mocked this thing, the school, I'm going to close this, the school admin, sorry, I've mocked it. And now this is the difference in the assertion. I am not asserting the state of anything. I am not asserting that the windows are actually closed. What I am asserting is the behavior of the methods and the school admin mock itself. I am asserting that shut school due to a fire method has been called once, and I am asserting that school admin, that this method has been called with these arguments, with lab windows. Okay, do you see the difference between the state assertion and the behavior verification?
Yes.
Okay. Okay, cool. So we are not basing the assertion of our test in the state of something, but the behavior. Okay, so we are asserting that it has been called this method with these arguments. Okay, so let's run the test. And this should pass. Cool. Let's see, because this sounds a bit like that. So let's see here. Let's see that I do now. Lab for Windows. This test should fail. Okay, it failed. Okay, expected lab for Windows, but actual got lab for Windows. Okay, so basically this is how it should work, but we're just going to take like a quick look at it because usually we all use the Mockito framework. Okay, so what we are doing in this chat school due to a fire method is we are passing as arguments the elements to close, and we are calling to the method invocation class, which is like a huge thing that has the params of the method, add param of the method, get the name of the method, set the name of the method, etc. Okay, and what we are going to do after this invocation is, okay, the invocation add params, the elements to close, and I'm going to say that the method shut school due to a fire has been called with these elements to close. And on this register call, I'm going to register the number of times that this method has been called. Again, this is just so that you get a grasp of what the mock do, but we are going to see it's so much easier using the Mockito library. Okay, so let's going to open the Mockito mock example. Desktop, I hate to do this all the time. Thoughtworks, WomanUp, examples, TDD, Mockito mock. Okay, so Mockito is a library that we can use for mocks and spies that actually works really, really well. Okay, so basically we have the same thing. But now, as you see here in the test, let me start closing things. The dummy. The fake, I want it no longer. Come on, the stub, I don't want it. The mock, okay, now I do have the mock and the Mockito. Okay, so now in the test folder, I don't have to create an school admin mock with the Mockito. Why? Because Mockito is going to create the mock itself. Okay, so the same thing, the same error in the method name, because I copy paste things really well. Where is this? Okay, this here and this here. Okay, so should close lab windows when fire declared. What I'm going to do now is I'm going to Mockito with the mock works this way. You create the instance, you mock the instance of the class. Okay, so I'm going to create a mock of the school admin implementation class, which is the same as previously. Okay, when it's called to the shut school due to a fire, actually that's on reality it does actually starts closing the windows and whatever, but I've put this trace because of something I'm going to tell you now. No! Okay, so we are going to create a mock of this class. We are still going to call to the shut school due to a fire the same thing, and Mockito verifies the verification of Mockito of the behavior works this way. We are going to verify that a school admin mock has been called. That the method shut school due to a fire of school admin mock has been called with these elements. Okay, so I'm going to run it. And it's going to pass. Okay, but let's debug it because this is where the magic happens. So I'm creating a mock of the school admin class. So when I step into this method, what do you think it should call? Should it call the actually shut school due to a fire method of the school admin implementation? This one?
No.
No.
It should call a fake one, right?
Yes.
Yep. So by using this library, we do not have to care about the class. Mockito creates the class itself. So we do not have to worry about the creation of the mock. We just, by using the mock, we are making sure that we are not calling the actual thing, that we are not closing the windows and the doors. Okay, so if I click F7, poof, look what I've got, something that I don't know what it is, blah, blah. I'm sorry, do I have a, yeah, I have a breakout point here. Blah, blah, poof. And now I've ended. Okay, F8 and run. Resume program. Okay. So, I went. It has gone. Okay. Let me just click run then. Student test. Let me just run the test. Okay, so here is the output of our test. Seems weird, right? I mean, not weird, but in here we have a system out println closing. So if we did actually called this school admin implementation, we should have seen this printed here, but we haven't. So it seems okay, right? We are calling the double. We are actually calling the mock. It's mocking this thing, but it's not actually calling the production code, the object itself. Why am I insisting in this? Because of the next, we are going to see the spy. So the spy open works similar to the mock, but it calls the method of the real object. Okay. We still Thoughtworks, WomanUp, TDD, Spy. Okay. If it opens, claro, si no. A ver. Why won't you open? I think that my laptop is about to die. I don't know why they won't open. Open. Oh, because it's opening in the other screen. So nice. Okay. Can you see the spy example?
Yes.
Yes.
Okay. Okay, cool. So we have, for example, in this spy, we are testing send message to a student when successfully enrolled to class. We are creating a student and we are creating a student spy. See that we have the same method invocation we are seeing that in the mock. Now we have the student spy, which is kind of like the mock, okay? But what we are going to do is now in our student, we have to add a method that it's called setSpy. So we kind of add that spy to this student. We kind of put them together. Okay, so student setSpy, blah, blah. What are we going to test? Enroll to class. What are we going to assert? Again, the behavior. We are going to assert that enroll to class method has been called once and with these arguments. Okay, so let's go into test. Okay, finished again. Okay, so everything has gone as it should. The method enroll to class has been called only once and it has been called with these arguments. Again, Mockito, we can use Mockito also for Spies. So I would rather, this is just for you to see how it works on the inside. We just creating an object that registers the calls to the methods and how they are called. So if we open the Mockito one, again, Thoughtworks, WomanUp, examples, TDD, Mockito Spy. Okay. Okay, so as you can see in the test, we as it happened in the mock, we do not have the spy because we don't need it because Mockito is going to take care of it. So now what we do here is we create our student, we say, okay, remember that in the mock we were mocking the object itself because in Mockito mock what we passed was the class itself, the instance of the class. But now I'm sorry, the class itself, not the instance. But what we are doing here in Mockito is, okay, I want to spy this object, this specific instance of the class student that is a student. And I'm going to do the same thing, enroll to class. And I'm going to verify that for this student spy, the method enroll to class has been called with these arguments. Let's try. Oh, it passed, but this enrolling, where this enrolling comes from? Okay, so it's from the actual object itself. So remember that when we were using the mock, we were creating like a totally different thing, and we couldn't see the print that that was in the method that we were testing. But here in the spy, we actually see the print. So basically the difference between the mock and the spy is that in the mock, Mockito takes care of the creation of the mock itself, but on the spy, we kind of attach it to the actually production code, okay? So we are actually doing things with the production code, but we want to make sure that it has been called the times that it needs to be called, because with the spy we can also say like it has been called 2 times or 3 times or whatever times we need to have been called, and the arguments that it should have been called with, that it's test class. If I put here test the class, it should break. Okay, it's broken. Arguments are different. It even tells me what is going on, right? Arguments are different. Okay. Do you see is it clear the difference between the mock and the spy?
Yeah.
Yeah.
Yes?
Yeah.
Everything, yes?
Yes.
Cool, cool. Okay, so I said that I was going to be until 11, but it's 11:36, so sorry. So maybe we could do like be here at 11:45, 11:50, and take a little break and continue.
Okay.
Okay.
Sounds good.
Cool. Okay, see you in a bit.
You.
Bye.
Ciao. Resume. Thanks. Thank you so much. Okay, so as we've mentioned before, unit test, what we called unit test, it's kind of a difficult terminology. There are a lot of discussion. Some people say that the unit of the unit test should be a class, but I'd rather say that it's better that the team decides what makes sense to be the unit for the purpose of their understanding the system and its testing. Okay, so it's not do not think that unit is the class, and when we say we are doing unit testing is we are testing a class, because it might be a little bit broader. Okay, so basically they are low level and focused on a small part of the system. This, yes, I mean unit is not always the class, but it cannot be like the whole systems. Okay, so it's low level. It's basically what we have been doing is little tests. It's the fastest of all the tests. and we run them after every change we make of the code. Imagine if we have a big project and we have really isolated components. Maybe we do not want to run all the tests of the whole project. Maybe we want to translate that verification to our pipeline. But we can at least, or we should at least run the tests of the components involved in our scope, okay? So maybe we do not have to run all the tests, but just the tests of the component that we are touching. Okay, the next type are integration tests. This we've mentioned before also, and we use them to determine if independently developed units work together well, if there are no errors. As we mentioned before, for example, reading or writing from a database would be an integration test, and they are not as fast as unit tests. So that is why we want to create the test doubles in between other things. So we can double this database, for example, and we can also have our unit tests. We have also the contract tests. So what we do in these tests is we check that all the calls that we do against our test doubles return the same results as the call to the external service itself. So for example, imagine that we are doing some calls to a REST service, to an API, an external. It's not, we want to connect, I don't know, for example, to the mailing service of Google, of Gmail, for example. So maybe we want to have a contract test so that when imagine that they update the version or they change the signature of a method that we are using, we get to know it. Okay, so I don't know whether if you can see this image here really well. So basically what we have is our integration contract test. It's connecting directly to the remote service that we are using. Okay, also we can create test double in order not to do so and to be able to detect if our code is doing something wrong. But we might also want to have this contract test to see if an external service has changed and therefore it's going to break our code. Okay. Okay. Good. There was a question, sorry?
Oh, sorry, I was going to say, okay.
Okay, cool. And also we have exploratory testing. Exploratory testing is basically manually, and it's when we have a web application and we want to see that the design looks correctly and that all the workflow works correctly and all that stuff. We can also do automated testing of the UI by using some tools, some libraries like Selenium and Cypress, I think it is. It also allows you to do testing by doing by simulating clicks on the page as if you were a user. I forgot to put this here, but let me see if I can find it quickly here. Testing pyramid. Okay, let's use this one of our beloved colleague, Martin Fowler. Okay, so basically we have to take into account what we call the testing pyramid. The testing pyramid establishes, or it's good to base our test on this. So take into account that our unit tests, when we do unit tests, they cost less and they are faster. So it makes sense that we really have a lot of unit tests because we can execute them really quickly and without any costs. Okay. Then service or contract testing or whatever, they cost a little more money and they are a little bit slower. So we should have maybe less service or contract testing. And then the UI, obviously it's the one that it's slower because you have to manually go over there, take a look, and it also costs more. So this pyramid, what established is the amount of each test that you should have. So based on this, what you should have is a lot of unit tests, then less contract or service testing, and the least tests you have are UI. Okay. Okay, so I'm going to close this because I just wanted to show you the image. And
yeah, sorry, everything boils down to you don't have to spend more time testing than programming. So unit tests are easy, so you make more. UI tests are difficult, they are expensive in terms of resources, so you do less.
Yep, that's right.
Okay.
Yeah, so basically this can seem like a little bit that you have to follow this rule, but if you actually do TDD, you organically end up having this, because for every single thing that you want to do, you are first doing the test. So at the end, you are going to have a whole lot of unit tests, and then you just have to add the contract test to see whether if the mail service is working correctly, or the integration test to see whether if the database is actually storing the data correctly. But the greater number of tests you are going to have are unit tests, because it's what you have used to base your program on. Okay.
Okay.
Cool.
Thank you.
No worries. Okay, so now testing techniques. We have, for example, the feature toggles. Has anyone used feature toggles before?
Yes.
Yes. Some no's and yes. Okay. So basically, feature toggles is some patterns that allow you to enable or disable a certain functionality so that clients or users can access to that functionality or not. Let me open my IntelliJ again. Open desktop. Where was I? Thoughtworks. Here. WomanUp, examples, TDD, feature toggle. Okay. Okay, so for those of you who were in the previous workshop, do you remember this code that we used to see the strategy pattern? If you weren't here, it's really easy. It's just we have a billing strategy, and we have a normal strategy and a happy hour strategy. Basically, when we say that a customer, we are setting the strategy to happy hour strategy, what it does is that the price of the drinks is half the price, okay, during the time that the happy hour strategy is applied. Okay, so imagine that we are developing this thing, and we have just opened our bar, and we want to try to implement the happy hour thing, but we are not sure whether if it's actually going to work or not. So while I decide that, I can program it, but I do not want to make it visible in production. So what I do is basically feature toggles are an if. So if I pass as an argument to my main program a feature toggle, it will apply the happy hour strategy. If not, it won't. So what I can control here is this is also like really useful for CI/CD, because I can it allows me to push commits into the main branch and take them to production, but not being able to anyone, okay? Because I am saying, okay, to only show this, to only do this, if I pass feature toggle as an argument to the main. But on the execution, on the normal execution of my program, I'm not going to pass feature toggle. It's just going to execute at java -har, whatever, blah, blah. Okay, so this is really good for CI/CD because it allows us to keep pushing things even though we don't want them to be in production. This example is for backend, but you can also apply it for frontend. What we usually do is we have an URL .google.com. So if afterwards we said, okay, we said google.com, and then we add a parameter to that URL that it's feature toggle, for example, equals on. And what we do is that we read in our application, we read that URL and we say, okay, if in the URL we have the feature toggle you want to on, then show me this new component. If not, which is where the usual users are going to go, do not show it. Okay, did I explain myself well?
Yes.
Maybe yes, maybe
Yes.
not.
Yes.
Yes? Okay, cool. Okay, so next we have what we call Canary testing. So Canary testing is based on the idea of miners that took canaries to the mines to see whether if the air was breathable enough for them to go into the mine. So if the canary died, they wouldn't go back. And if the canary survived, it was safe for them to go there. So basically, it's the same thing. We are releasing software, new software, to a small percentage of the users. So we got to see whether if the new percentage of users are doing, also you can add some measure things like Google Cloud Platform, Sentry, or whatever, to see whether if those users are using your new version or your new functionality. So just a little percentage of the users are going to see the new thing. If when you deploy this and the little percentage of users that see this thing are filling out your help desk tool with error tickets, roll back because obviously there's something going wrong, but you do not impact the whole of your customers. Okay, it's just a small percentage to see whether if your new thing, it's people like it, or it's working, or it's creating any problems. And also in this kind of spirit of the Canary testing is the A/B testing, but this one is kind of more broad. So you deliver, it targets all your audience, but for example, you show to a 50% of your users one version of your application, and to the 50% the other version. Okay. So if we use this, and we also have, as I mentioned before, the GCP measuring stuff, or where we can see the conversion rate of buttons, we can see which version of the two of them is the best. So imagine I have a web app, and I've usually had the login button in the left side screen. But now I say, okay, maybe I want to move it to the right side screen. So I deployed the two different versions, and I see which one has a better conversion rate. Maybe the ones of the right have a better conversion rate because it's where login buttons usually are. Maybe the ones that have it on the left are not clicking on it because they don't see it, and they are accessing the login through another place. Okay, they have to go to another website, or they go down and find a link that says login. Okay. Okay. And now we are arriving to what I didn't want you not to see here. Golden master. Okay. So same hypothetical situations that we've never been on. You run into a legacy code that has no tests. Never happened to any of us. Okay, so what Golden Master allows us is to modify the code with the certainty that we are not going to break anything. How are we going to do this? Because remember that we have a code with no tests. So let's see the example. This is like a game changer, this thing. Okay, so let me open the Thoughtworks WomanUp. Did any one of you have heard of the Golden Master technique?
No.
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 Oh, so nice, so nice. Ugly trivia. Okay, this is going like you're going to feel like your brain has been expanded right now. This is like, oh my God, this is like a really nice solution to my problems. Okay, so imagine now we have this project in TypeScript. Close all tabs. Okay, so we have kind of a trivial, but it has 3 components: the game runner, and the stack of questions. Okay, and we have, okay, this doesn't seem to be like a lot of tests, right? Okay, in fact, there was no test because I've just put this. So you have a trivial game which has like a whole lot of code, but I don't know what it's doing because this is just, what the hell is going on? I don't know. Game, how many players, player run, this is an if, and player move and roll dice, and well, I don't know what's going on. Okay, so what we do is we create our first test, and we say, okay, new console log. The important thing about this, what we are using, is because this is simulating a trivial. So in some part, we are simulating a dice. So this might be a bit tricky because dice can happen, are random. So what we are going to use is the seed random, this thing that says seed random. And what it allows us is to run the tests always with the same seed of the random. So we can always be certain that we're going to have the same numbers, and therefore we are going to be able to do what we have to do next. So what we are going to do is that we are going to create a text file of all the outputs, okay? So here it says that it's going to do export, the right says was added, there are play number because what's it's here. Oh, okay, so what I'm doing is all the console logs of the game, I'm going to paint them in a new text file. So what I'm going to do is that with every single change I make in my code, I'm going to compare the previous snapshot, the previous text file, to my current text file. That way, I'm going to make sure that I'm not breaking anything just by comparing the text. Okay, you can compare it in Notepad or whatever you want to do. Okay. Sometimes we even don't have the console log, so maybe we have to do that manually ourselves, and we have to introduce the console logs that we want on the legacy application so that we can use the Golden Master. Okay, did I explain myself well?
But so if there's no logs, let's say, you would add them then.
Yeah, if there are no logs, you should add them, because what you are going to compare is the logs of the application that works but has no test with the logs of that the application outputs with the changes that you are going to introduce, and it should match. That way, even though I do not know what the application is doing, I know that I'm not breaking anything. Okay, because both texts, both text files are going to be the same. Okay. Do you understand it?
Yeah.
But I can't add a log in the new functionality, I suppose.
Would you want to add log? I mean, this is I'm a tricky question. So the thing is that we wanted to add logs to our legacy code because it has not tests, it hasn't got any tests, and it's an easy way for us to be able to be sure that with our new or our refactor, we are not breaking anything. But if we are introducing new things, we really do not want this console log. What we should do is use TDD. Okay. So instead of adding console logs, what we should start doing is TDD. So that way we make sure that one, our new functionality is going to work, and two, we are not breaking anything that it was done before. Even if I don't know what the hell it was doing before. I mean, to be honest, I don't know how this trivia works. I just want to make sure that I'm not breaking anything with my refactors. Okay. Flor.
I have a question.
Sure.
How would you push this to production with the console logs?
You can, if you are using Git, you can add this log to the Git ignore so that Git will ignore it and you won't have it in your GitHub repo. You have that option.
Okay. So,
or maybe what you can do, what you can also do is not add it to the Git ignore, but you can create a branch named Golden Master, for example, when you actually update these console logs, and you can work on that branch a little bit, not too much, because if not, you are kind of breaking the spirit of CI/CD, but at least until you are confident enough to merge it into master again, and then ignore the snapshot.
Okay.
One question. The main purpose is refactoring this legacy code, or the main purpose is creating the test for this legacy code, and in case you needed, you were going to refactor it?
So the main purpose of Golden Master is not to break anything. I mean, it doesn't matter whether if your task is to refactor what is already been coded or to add new functionality. Because I don't know how it's worked. I mean, this is quite simple, but if I have like a monolithic thing and I don't know all the components, I just want to make sure that I don't break anything, whether if I'm refactoring or whether if I'm adding new functionality. So the way that I make sure is I save all the console logs in a text file, and that way I make sure that I'm not breaking anything, because the two text files should work. Let's see. For example, okay, let's do something in here. I don't know what can we do. What can we do? For example, I see that here in the game I have an array of players, and I'm going to add a name and only have this. How many players? Player turn. What other things can I have? Let me see. Here. Let me see. Whoops, sorry. Hit the wrong button. Let me see here that I can see better. Okay, so but now you cannot see this. Okay. So for example, me personally, I do not like booleans that I have to work with the negative. I don't know if I'm explaining myself correctly. So boolean no winner. Maybe it's better to have a boolean that is actually the winner, because in my mind, it makes more sense. Okay, but this is just in my mind. So maybe I can rename this Boolean to there is a winner. Okay, so if there is a winner, then I can rename this here, and I guess that it should be while there is not a winner. So if game has played correctly answered and and not, the game didn't win. Wrong answer was correctly answered. No, it would be the other way around, right? I think so. If game has player correctly answered, there is a winner. If not, didn't win. And if game did. Okay. So I'm sorry. If else not. Okay, imagine I'm just doing this. So I say, okay, I don't know whether if this is going to break my application or not, because I do not have any test. But lucky me, I've got the golden master to compare the output of this to the output of the previous version that I'm certain that it worked. So what I will do is I would go here, I would run the tests. It's taken a little bit because it's not that fast as it should, as a unit test would be, because it has to compare the two text files. So it's going to take a little bit. Okay, so on the meantime, but what we are testing is, okay, I want the new console log of this execution to match this snapshot. It's from TypeScript, and it's used to match this thing on the snapshots folder. Okay, so to match snapshots is to match this thing. And I don't know why it's taking so much. Maybe I've messed it up. Maybe I've put here something wrong and now it's on an infinite loop. Let me remove this and stop. And run it again. Or maybe it's just that my laptop is a little bit small. It's going to. Okay, but do you understand the spirit of the Golden Master and how to use it?
Yeah.
Yes.
So this is like life-saving when you have legacy code that has no test, because I don't even have to worry about what it does. I just want the output to be the same. And it gives me like such a confidence that I'm not going to break anything.
But if you're constantly working with legacy code, then you could use this initially, and then you'd have to add proper tests.
Yeah.
Okay.
Yes. I mean, ideally, because as you can see, it's taking too long. For me, this is now too long. This is what happens, and programmers go, okay, I'm not going to run the tests because it's taking too long. This is not a fast test. This is not what we could use as a unit test to give us the safety net, because if it's going to take like 5 to 10 minutes to run a test, it kind of encourages developers to not run the test because it takes too long. So basically you can do this, but as you are refactoring or as you are introducing new code, the ideal thing is to little by little start adding your tests. So at one point you won't have to rely in the Golden Master. Totally agree. Okay, so I'm going to close this because it's taking ages, forever.
But I'm still confused. I mean, you have to rely, I mean, with this, you have to rely on your output. Like it has to be complete somehow, because if not, you can have false positives somehow. Or
Yep. Yeah. It can. I mean, if you are lucky enough, the legacy code that you work with would already have the consoles that you need. But it's totally true that you must be very careful with where you put your outputs and what outputs you put. Okay, so true. In this case, we already had the console logs because it's usually a common thing when people don't do tests. What do? They spit it out as an output because it's their way to make sure that everything is working correctly, right? We have never seen this also. We have never seen a program that spits out a lot of things. Why? Because they don't have tests. So what developers usually do? They put outputs so they can see what's happening because they don't rely on their code because they don't have tests. So this is kind of a nice way and a nice situation. But if you do not have even that consoles, you would have to add them and you would have to be really careful where to add them. I agree. So it's not like a silver bullet, but it's really, really, really helpful. Okay.
So you could have them actually, I mean, if you have a login system, then you can push them to trace level and then have them in production even because nobody's going through.
Sorry.
So let's say you have a login system and then you have different levels. So you can, I mean, you can decide, okay, these outputs are going to be in the trace level, which is the last one. And then, I mean, if you want to debug with the client, then you can stop at debugging level and then have your trace to do your tests or something like that. And then you can keep it in master with no, I'm asking, or you have to remove them. I don't know.
But you can always, when you are generating the production version, there are lots of, well, I never speaking about NPM and Node, but you can always use Webpack and there is a, how it was applied, I don't remember the name, that you can remove the logs. So you are not going ever in production code to have any log. It's like the same that we use Slint or Pretty or these kind of things. So you can have logs in master, but at the end in the production code, you don't have those logs in the code. Yeah.
But do you want the logs to be in GitHub for a specific reason, Paula?
No, because I was thinking if I'm adding, so I'm refactoring now today class A, but maybe in 2 weeks I have to refactor it again. So it's nice for me to have what I did 2 weeks ago, because then I would have to work on that again and maybe refactor another.
But if you are refactoring, you should now be using TDD. So I don't get what I mean. I don't see why
maybe I'm just confused. So
no. I'm
so
certain
I
I'm
have
not understanding
legacy. I have legacy code and I have to do a new thing on one class. But normally functions interact with each other, and then let's say I'm putting the logs in a function that affects another 3 functions, and I'm refactoring. I'm doing a refactorization that implies changes in 2 of them. And then two weeks later, and then I add my traces to the first function. And then 2 weeks later, I need to do a refactorization that implies changes in this third function that depends on the original one where I added traces. So then it is nice for me to have them already so that I don't have to do the work again. Or maybe that never happens. I don't know. So I'm just thinking as I go, maybe it's just.
So what I think I would do is, okay, so I have these 3 functions. So first I would create the logs. And then while I'm doing the refactor, I am running 2 types of tests. I am running the unit tests to see that the new things that I am refactoring are I mean, I will do TDD, and I will also keep the logs, and I will also, run the tests using Golden Master. to make sure that the two logs are the same. But now that I'm finishing the refactor, the first iteration of refactor, and I have finished the refactor of my two first functions, for example, using TDD, and I know that by using Golden Master, I am not breaking anything, any legacy code. Does it still make sense to keep those logs? I think not, because you are actually now you have used Golden Master as a safety net, so that while you are doing your refactors, you don't break anything previously. But the new things you have done, you have been using TDD, so you actually have tests that have covered your refactors. So on the next iteration of refactor, you can start using Golden Master, but just for the new things, because you don't want to break new things. So while you are on that process on refactor, you can still use Golden Master as your safety net to take a look. I mean, to ensure that you are not breaking anything that was already done, but you can use TDD to help you with your refactor. I don't know if I'm explaining myself correctly.
Yes.
Quite well here.
Okay. So my concern was about another function that had an explicit or implicit dependency on the other three, and then, I mean, okay, right, you've refactored two of them, but then, I mean, let's say there's another function you are using, but you're not refactoring somehow, but you need iterators on that to make sure. So in that case, I would keep them in this other function. I don't know if I explain myself.
I mean, if they are so intricate because maybe they are not correctly encapsulated and they have like they are like highly coupled, maybe you can in that case upload the text of the Golden Master. You can. I mean, it also depends on how the code is done. If it's like tightly coupled and you know that you might going to need in the following week, you can upload maybe you can create a Golden Master branch that it doesn't live too long, and there you can do all this stuff. And then when you are certain that you have finished, you can remove the logs. I mean, if the logs are, yeah, that's how I would do it. Maybe other people would do it the other way, but that's how I would do it. Okay, and any other questions or doubts?
Yes, I have one question. So speaking about legacy code, as you say, imagine that you have a method that is already existing, it's legacy, and you're going to refactory. How do you work with it with TDD?
So,
will be the steps?
What I understand for legacy is that it doesn't have any
something
test.
that someone else did like 1 year ago, and then you need to refactor it.
And it doesn't have any test.
No.
Okay. So first I would do the Golden Master thing, because maybe it's, if I want to refactor, is that something is smelling wrong. Maybe. I'm just assuming that I want to refactor, maybe because it has like a huge if somewhere, and I want to refactor.
Or imagine a migration, or what I'm doing right now. Imagine a migration from JavaScript to TypeScript.
Yeah, so you can do the Golden Master to see that the outputs that you want to control are still the same, but also if you are migrating on the new migration, even though you might know what the method looks like or what it has to do, maybe you would want to start doing TDD, because maybe you end up with a different refactor than the ones you thought of. Maybe you end up with another idea, because you start by doing TDD. It's like you start from the bottom, and you, I mean, when I'm saying that your brain goes through your nose, is because it totally changes the way you think and you approach a problem. So because usually if I've been here, if someone tells me, okay, let's do this, and I start thinking big, And I say, okay, maybe I should have a class student that has the school or the class or whatever. And I start like making my mind up. But maybe you are not doing exactly what you should be doing. Maybe you are doing things that you are not going to need. So what I would do is just keep the golden master of the outputs that you are certain that you are going to need. I mean, okay, I'm going to put an output here because this is what it's going to print me the result of this function. And now when I'm changing to, I think you said from JavaScript to TypeScript.
Yeah.
I think. Okay, so I want to make sure that now this function, even though now is in TypeScript, is returning the same value. For the same inputs, is returning the same value. Maybe you want to add the extra layer of TDD because maybe that function, it can be refactored, not only changing from JavaScript to TypeScript, but maybe the function itself needs a refactor, maybe.
Yeah.
I mean, if you can, if you have, sometimes it's difficult to sell TDD to non-programmer people because when you see a pairing, when you are in pairs and they are doing TDD, what you see from the outside is like a lot of chatting and not too much programming. This is what they see from the outside. But that lot of chatting is so useful. So useful because what you first, by doing pairing, as we talked last week, you get another point of view. If you are committing any errors, if you are doing any errors, you get another pair of eyes to take a look at it. So maybe those new pair of eyes get to spot the error that you didn't. And also, as we've seen previously, and as Paula mentioned, the naming. I mean, I don't remember how many conversations about naming I've had and how many time I've spent discussing about the naming of a method. Maybe that discussion takes more time than the actual implementation of the test. But now the question is it worthy? In my opinion, yes, because I am not working for me, but I'm also working for the future. If I get sick and another teammate has to go into my code, he gets to see what the code actually does, but by that name. I mean, this is like a new melon. In Spain, we say abrir el melón. This is like a new melon we can open because the naming thing is like, okay, we can be discussing about naming, about how we can name things. But for me, the naming is really important. So I'd rather spend more time or some more time discussing with my pair about how to name something so that the intention of what it's doing, it's so clear that if I get sick and tomorrow someone new has to come in, he doesn't start pulling out his hair thinking about what my code is doing. I know this has nothing to do with what you've asked, Sendami, because my head tends to go away, but I don't know whether if I answered your question.
I know where you are going. Yeah, I know exactly where you are going. Yeah.
Okay.
Yeah.
Okay.
Well, in my case, the problem is that the company thinks that programming is a waste of time. Even I'm doing it, but yeah.
I mean, this is like a recurring conversation everywhere you go. It's like if you are, some people may look at, if you are doing so many tests, you are not programming, so that is a waste of time because they don't see the really importance of tests. That is not only to have a test, I mean, a code that works, but a code that it's easy to maintain and it's not too complex and might not have, as we said before, many bugs. So for me, it's not two separate things. I mean, I do not pay more attention to the code than to the test. I pay the same attention to both because one complement each other. And I'd rather say that if you do not have a good amount of unit tests and a good quality of unit test, you can apply all the design patterns that you want to your code that maybe it's going to be shit. Because maybe it's going to have a lot of bugs. So that's why for me, test is so important. And that is against what I've been taught in university. In my university, tests were like a second thing that you used to do. So this is why for me it was a bit difficult to start paying so much attention to the tests and actually discussing, because also if you think about it, when I am implementing the tests, I'm also defining how my component is going to behave. Because I'm going to say, okay, so I'm going to use these classes for the arrange, and I'm going to I'm going to test this thing. So now I'm saying how my components or how my classes are going to behave and how they are going to be structured. So I am designing, that's what test-driven development. I am designing based on my test. I'm giving based on the way that I'm doing my tests and how I am doing my tests, I'm defining the structure of my code. Okay.
Yeah.
Cool. And I know it's difficult. It's difficult to sell that idea. I know.
What I found is very difficult when you have when you are doing that kind of refactor, something that is already done and it's a method that is doing like lots of things. Do the baby steps, because it has so many things included that it's like, oof, what could be the next baby step? It's funny, very difficult that part.
Yeah, so that is also I mean, it happens, but that is one of the things that TDD helps you with. I mean, if you are starting from 0, it also helps you see when maybe a function is growing too big. Unfortunately, if you run into the fact that you have a really long function, if it's a really long function, it means that it's doing much more things that it has to do, because functions usually are short. Maybe something is going wrong in there. But what I would do if I had this long function, I would have the golden master, and then maybe I would start by extracting little things. The first thing, it doesn't matter whether if it's the right thing to start with, but it's just the first thing. Imagine that we have the calculator, and instead of having the add method, the subtraction method, and the multiplication method, we have just one method that it's calculate, and based on the input, it does an addition, a subtraction, or a multiplication. That's a smell, because that is a function that it's doing much more things that it should be done. So maybe I would start by extracting the addition to a new method. I don't know whether if at this point, I mean, it's a simple function, but I don't know, this example is a simple function, but I don't know whether if it's the exact right place to start. But I know that this is a baby step that it needed to be done, because this function is doing too many things. So what I would do is I would extract the addition to a new function, and then I would run the golden master. I don't know if it's exactly the right step. I mean, maybe instead of starting with the addition, I should have started with the subtraction. I don't know, but at least it's something that I'm doing. I mean,
yeah, now that you're telling me that, perhaps I'm thinking that when this kind of things happen, that you need to extract the small functions, perhaps it's a very good idea before extracting those functions, create the TDD test for every function.
Yeah, totally. I mean, if you have the opportunity to have both the golden master to make sure that you haven't break anything, and the new extraction of the function, the refactoring using TDD, that's awesome. That's awesome, because maybe by doing TDD, you discover that the addition is not been doing well. That could be another thing. I mean, I have the two golden masters. I know that they are doing the same output, but maybe the addition is not being done correctly. That is something that has never happened to any of us.
Yeah.
So I recommend that you keep that, but also the new functionality or the new refactor, you use TDD, because you might discover some things that you didn't know. Okay.
Yeah, that's cool. Thanks. Yeah.
No worries, Endami. We're here for this. Okay, so let me see, because I think that was it. Cool. Okay, so do you have any further questions or any more questions, or you want to ask something, or you are already tired of me because
I would like to ask you something.
Sure.
regarding the coverage tests. I don't know where and in which part of the process do you use this kind of test. For example, in my case, that we don't do TDD, we use coverage test in order to check on everything, or all the missing tests, and start coding the tests. But I'm not sure if you use them, or how do you?
Yeah, so to be honest, I only think one place that, one project that I've worked with, and what we had was a Jenkins that when we did the push to the commit, it would run the test coverage. But to be honest, because we've already done TDD, it's actually when you do TDD, it's not that much. It's not whether if I covered every single line of code, but rather the functionality. But yeah, because I think that when we pushed it, Jenkins would tell us the test coverage, but I can't remember how we proceed, because we did it just like this for 1 or 2 weeks. Let me think. How was it that we did it?
Yes, I think it is very useful for us, people who don't work with TDD, because it's useful for you to notice which are the functionality that has no test. So you can start working on those tests that are missing. But of course, let
me tell you something.
But it's
and the danger about that is that this is how our mind works. When I was in university, I used to do my practices and then pass it. Even though I had my code and my test, I would let a colleague, a friend, to execute and try to break my code, because the danger of doing tests after the implementation is that your brain knows what you have programmed, and you are kind of biased, and your tests are biased by the code you have done. So it's really easy to miss those corner cases. Sorry. So if you can, you do not have the opportunity to do TDD, right?
No. But I like it. I think it is very useful for you to start thinking in that way, rather than in the other way.
Yeah, that's what you think now. The first day you would hate it, but the second day you would love it.
I think it's right. It is kind of if you are so used to do the things in a certain way that it's very hard for you to. Oh no, I forgot to start with the testing. So that is I think it's about practicing, and more than Also, you have to convince people that you are not wasting time. That is.
Yes. Convincing people is it's the hard part. But for me, it's, as we mentioned when we started the workshop, is okay. If you are asking me to do something that I don't know, a dish that I don't know, I'm not going to start putting the chicken and the lemon and the almonds without knowing without knowing how it works or what to do. I'm going to start with the recipe, and the recipe is going to tell me how to do it. So it's like counterintuitive, but at the same time, it's what we usually do. So to be honest, I don't know. Well, I know why it's counterintuitive, because it's not the way that we used to do it, but only for programming. But because when we are cooking, we are taking the tests, that is our recipe, that it tells us how it's going to work and what we have to do, and then we are going to implement it. So it's kind of tricky. But yeah, I would just say that if you have the coverage, I don't know, maybe I'm just thinking out loud. Maybe I don't know. Let the another developer that wasn't involved in the programming of that function do the tests, but do the tests like he would do the TDD, even though if it's not doing TDD because the function is already done, but that he think with a TDD in mind, which is when I add 2 plus 2, I want to return 4, even though we are not doing TDD. But I think that it's a good idea that he should think in that way, so that he can both work in that function and detect possible bugs that you have not detected. I'm thinking out loud. Maybe it's not even a good approach for your case.
Yeah.
Cool.
Thank you.
Yeah, no worries. I'm just that's it. I'm just thinking out loud. Maybe it doesn't apply to you because you are a small team and you have all worked in the same thing. But at some point, if you cannot do TDD, I would suggest that, because that kind of simulates the breath of fresh air that TDD simulates to give you. It's just, okay, you start doing these tests, and even though we already have this implemented, but try to do it like in the TDD way, which is baby steps, and let's see if the function still works. And if I put, like Paula said, let's try, instead of when we were doing the calculator, instead of doing the integers, doing the floats, even though the function is already done, but that should break our code. So, oh, maybe we have to change the function.
Yes, totally.
Cool. Okay. Any other question?
Yes, I have one question.
Yep.
Do you usually refactor the tests themselves? I mean, for example, when you have several tests with the same arranged parts, some a little complicated, do you extract functions or?
Yeah. That's a really good question that I forgot to mention. So if you are doing too many tests, and for example, as we were seeing with the school and the class things, imagine that I have all that in the same test suite, and I'm also each test I'm having to create the student and the class. So we can extract that to a function. So we can do two things. I think that is a Spring Boot. It has two different types of, no, or JUnit, I don't remember which is this. We have like two different kind of annotations. The before test, which runs what you have in that method just beneath the at before test. It runs it every time you are going to execute each test, or you have the at before all tests, I think. That it's if I need a general setup to run all the tests, I just execute that once after run all the tests. I don't know if I explained myself.
Yeah. I usually do that too, but sometimes it when you have a lot of different cases, then you join some of them, and then you need that you see that you need to change a little thing. So sometimes it's difficult because it gets more complicated when you refactor than that when you don't. So sometimes I have this interior conflict myself.
Yeah. So
I don't know if I should refactor or not.
What I should do is that I apply what I call the don't know how to say it in English, like the third time I step in the same stone. Okay. So I'm doing one test, and I am creating in the first test the student with name Juan, and I have the second test. And for the arrange, I am also creating the student Juan. So I say, okay, I've gone 2 times to the same sheet. Well, no worries. But now I have to create a third test, and I also have to create the student Juan. So I go, okay, this is the third time I've gone over creating the test, the student Juan. So what I'm going to do is I'm going to extract the creation of the student Juan, to another method. Okay, and now I have a fourth test, but I don't want to create the student Juan. I want to create the student Pepe. So maybe what I should do is refactor the method that I've just created for the creation of the student Juan, so that I can pass as an argument to that method the name I want to give to the student. So on my first three tests, I will call the method that creates the student with the name Juan, and on the fourth method, I will call the function that creates the student with the name Pepe.
Okay.
And so
Yeah.
that's how we usually deal with that stuff, so that you don't have to. I mean, on this case, because you are only creating a student, but imagine you have to create a student, a class, whatever, something else, and a Pepito. So you have 5 things. So instead of arranging, instead of having to initialize those 5 things every single time in the, type them in the arrange part of your test, you just call to the method that create them.
Okay. Okay, thanks.
No worries. Okay, cool. Any other question? Nope. Okay, cool. So what I'm going to do is now, or maybe this afternoon, I don't know, I'm going to send you a feedback form. I would really appreciate it if you could fill that form, because it helps me to see if I talk too much, if I talk too less, if I explain myself well, if maybe I do too much examples, too little examples. So I would really appreciate if you could fill that out. And also, I'm going to send you the Mars rover kata that we were talking about. I'm going to send it to you in a zip, so you can try to practice TDD with that if you want. I mean, this is totally optional, and feel free to send it back to me, and I will take a look at it, and we can have a chat and maybe start a conversation about the things or the doubts that you faced while doing this kata. And also next week, we will send you the link to the recording of the workshop, the slides, and the examples that we've seen today, okay? The ones of the test tables and all that stuff. Also, if while reviewing those examples or whatever, you have any question, do not hesitate to contact me. I mean, write me an email. Hey, Paula, I was reviewing the recording or the slides, and I still do not get the difference between a fake and a stub. Ask me. I mean, you have my email, and feel free to ping me. Okay.
Okay. Thank you.
Cool. So enjoy.
Thanks a lot. Very interesting one.
Thank you.
Yeah,
enjoy your weekend, and hopefully seeing you on the next one, which is the last one, the CICD one. So I'm not saying anything, but it's going to be controversial. Cool. Enjoy your weekend. Thank you very much for being here.
Thanks a lot.
Bye-bye.
Bye. See ya.
Bye.
Bye.